You're riding a skateboard and are going to attempt to jump the skateboard down a flight of steps. The drop of the steps is 2.5 meters. You jump your skateboard with a velocity of 6 meters per second at an angle of 20 degrees above the horizontal. Do you clear the steps and make it to the flat ground 6 meters away? How far beyond the last step or how far short of the last step do you land? As usual, we have our picture drawn. Here's your skateboard. You're going to be jumping at an angle of 20 degrees. That's going to be the bottom left corner of our triangle. Velocity in the y is upward. Velocity in the x is to the right. And x is going to be in red. And the y is going to be in green. We know the drop is going to be 2.5 meters. Now, we know from the problem that the steps are a total of 6 meters away in terms of our x distance. But we don't know that's how far we jump. The question's actually asking, do we clear the steps and land safely, or do we not clear the steps and land on the stairs, and in this case, we probably wipe out? So that's what we're actually trying to find, is how far do we go in the x direction? Do we clear that 6 meters, or do we not? So we're not going to use that 6 meters in the x direction as a number that we use to solve for anything. We're going to solve for the distance in the x direction and then compare our answer to 6 to find out if we cleared the steps or if we fell short of the last step. So now we're going to pull some numbers out of the problem. In the y direction, I know that we are going to drop 2.5 meters till we get to the lowest point of the steps when the steps are done. We know that the acceleration is negative 9.8 meters per second squared. In the x direction, we know we're trying to solve for the displacement, but that's the last bit of information we have. So in order to get the velocities at the beginning of the problem, which would be the velocity in the x direction and initial velocity in the y, we're going to do a little right triangle geometry up here on our triangle. The hypotenuse is 6. The angle in the bottom left is 20. So I'm going to solve for the velocity in the x direction using cosine. Velocity in the x equals the cosine of the angle, which is 20 degrees, multiplied by 6 meters per second. When I plug that into my calculator, I would get a velocity of 5.64 meters per second. In the y direction, we're going to do the exact same thing, except instead of cosine, it's on the opposite side of our triangle, so I'm going to use the sine. Velocity in the y direction is the sine of 20 degrees times 6 meters per second. When I plug that into my calculator, I get 2.05 meters per second for my initial velocity in the y. I'm going to take those two numbers, I'm going to pull them out here. 2.05 for my initial y velocity, and my initial x velocity, 5.64 meters per second. All right, if I want to solve for the displacement in the x direction in one step, just want to go right to that, I would know that displacement equals velocity multiplied by time. I have the velocity, I don't have the time. If I can get time, then this is a very easy problem to finish. So in order to solve for time, we're going to have to go to the y direction because we have enough information to solve for time there because we have three numbers, d, v naught, and a. I want to pick the equation without vf in it because vf is the thing that I don't have. So the equation would be d equals v naught t plus 1/2 a t squared. Nothing cancels out. D is not 0. V naught is not 0. So we're going to have to use the quadratic formula in order to solve for time, which means time equals negative v naught plus or minus the square root of v naught squared plus 2ad all over the acceleration a. We can plug in our numbers. So t equals negative v naught, and v naught was 2.05. Plus or minus, underneath my square root, I would have 2.05 squared, because v naught gets squared, plus 2 times negative 9.8 meters per second squared times d, which is negative 2.5. And all of that goes under the square root, and then it's all divided by negative 9.8 meters per second squared. I give myself a little bit more space there. When I plug all of that into my calculator, what I get is two potential times because of the plus and minus before the square root. And my first time is 0.95 seconds. And then my second potential time, if I plug into my calculator, would be negative 0.54 seconds. Now, we don't deal with negative time in this class because negative time doesn't make any sense. So math class, we would be worried about both numbers. Here in physics, we're only going to use the number that makes sense in the physical world, and that's not going to be one that has negative time, meaning our time for us to land our skateboard is 0.95 seconds. So I'm going to use this 0.95 seconds up here in the x direction, 0.95. And I can now plug in very easily and solve for displacement in the x direction. So the displacement would be my velocity in the x direction, 5.64 meters per second, multiplied by 0.95 seconds. And that means my displacement in the x direction is 5.36 meters, which is unfortunately short of 6 meters by 0.64 meters. So we would probably crash and have a pretty bad day.